Good morning, friends. Welcome to Water Resources Engineering class. We are dealing with Unit 4, and Unit 4 consists of two parts. One is groundwater hydrology. The second one is water requirement of crops. So we have completed already the groundwater hydrology, and now we are dealing with the water requirements of crops. In the water requirements of crops also, we have completed 3 lectures. Let us come. So what we deal today? So the theory part we have completed. Now let us take some problems in the same topic. So the problems, most of the problems are related to field capacity, right? Depth of water stored in the root zone, or some of the problems may be related to, for example, the amount of water to be really sent to supplied to the crop, or some of the problems may be frequency of irrigation. So all these type of problems we will try, but all of them work around only two, three things. Number one is field capacity. Number 2 is wilting coefficient. Number 3 is depth of water in the root zone. Number 4 is the frequency of irrigation. So these are the 4 aspects which you should know it. Let us see the first problem. Find the field capacity of a soil. So he wants the field capacity. What is the data that he has given? Depth of root zone he has already given. Existing water content in the soil. Already some soil moisture is available in the soil, that is 5%. And the dry density of the soil is 1500 kg per meter cube, and 600 meter cube of water is applied, that is the volume of water supplied, and there is 10% of losses mainly due to evaporation and deep percolation, and how much area is there is 900 meter cube. So this is the data. To be the field capacity means whatever is the moisture holding capacity of the soil, right? What is the available moisture in the soil? So there is already 5% of water content is there. So above that 5%, how much percentage of water is retained in the soil? If I know, because of the area is given, 600 meter cube is supplied, and out of that some 10% is lost actually because of percolation and evaporation. So that means out of 600, only for example 10% is lost, so remaining is only 90%. So 90% of 600 is how much actually? So 540. So 540 meter cube of water is applied to an area of 900 meter square. Area is in meter square. So that is the thing. Then let us say how much is the percentage of water retained in the soil. That is the question. So let us, I am seeing it. So total water is applied is this much. Loss of water is this much. So volume of water is equal to 90%, right? Then what is the weight of the water? So the weight of the water means how you will get it actually. So volume multiplied by the unit weight of water, and unit weight of water or specific weight of water, you know it, that is 540 into 9810 Newton per meter cube. So this is already meter cube. So this meter cube will go. So it is finally 540 into 9810 newtons. So that is what I have written here. Then what is the total dry weight of the soil actually? Total dry weight of the soil. Soil area is how much? 900 meter square into basically how much is the depth of the soil? 2 meters he has given. And what is the basically how you get the weight of the thing? First you get this 900 into 2 area into depth. This gives you what? The volume. Volume multiplied by basic, this is 1500 kg per meter cube. It is in kg per meter cube. But if you want, then if you see it volume multiplied by this, you are going to get only kg. But we need in the weight in units what? Newtons. So how to get it actually? 900 into 2, this is volume, into 1500, this is basically unit weight, which is kg per meter cube, into 9.81. This is what exactly I have put here. Once you get that, so total weight of water retained is known, dry weight is known. So weight of water retained by total dry weight, if you put it, you get 0.2. So that is 20%. So percentage of water retained in the soil is 20%. Already how much it is existing? 5%. And now added it is how much? 20%. So total what is the field capacity actually? So this 5% plus 20%. So 25% is what we call it as the field capacity. So let us take another problem. Now this time field capacity is given, right? Moisture content before the irrigation is given. That means 8% is existing. Determine the depth up to which the soil profile will be wetted with an application of 60 mm of water. So how much of water is being given? 60 mm of water. Take the dry unit weight of soil is 15.3 kilonewton per meter cube. So based on that, let us go ahead. So depth of water applied. So that is what we need to calculate. Why? Because depth of water applied is equal to gamma D by gamma W into D, basically that is depth of soil, into field capacity minus moisture content before irrigation. This is the basic thing. So if I use this equation, which you know it already. So gamma D by gamma W, how much? Gamma D is equal to, this is 15.3 divided by what is the unit weight of water? The unit weight of water is 9810 Newton per meter cube. In kilonewton per meter cube, if you want to write it, how much it is? The 9810 divided by 1000, it is 9.81. So that is what exactly I have put it. So I got it gamma D by gamma W, that I can substitute, and D basically. So what is the depth of soil? That is, I don't know. So that's what actually the question is actually. And field capacity has given, moisture content before irrigation also he has given. So 60 is equal to dW. So that is depth of water in the root zone. So that because that is 60 mm of water is applied, is equal to 1.6 D into 0.15 minus 0.08. So basically the depth of soil is equal to, that's what, 550 mm. So determine the depth up to which the soil profile will be wetted. That means we want to find out what is the depth of the soil. This is the second problem, right? Now let us see third problem. A loam soil has field capacity. Again, field capacity is given. Built-in coefficient given. Dry unit weight is given. Root zone depth also is given. Very good. Determine the storage capacity of the soil. Irrigation water is applied when moisture content falls to 14%. If the water application efficiency is 75%, determine the water depth required to be applied to the field. So how we will tackle such type of problems? Because equations are fixed. So now how I started actually, because the equation is available moisture is equal to gamma D by gamma W into D into field capacity minus building coefficient. Whether you call it as building coefficient, whether you call it as the moisture content before irrigation, all are same actually. If you don't mention anything, building coefficient you should give. If you mention that, that is the minimum level which we will take it. So this available moisture is nothing but the storage capacity actually. So gamma D by gamma W, same like in the previous problem. D, field capacity, built-in coefficient. See, gamma D by gamma W, this is already given to you. Depth of root zone, then 0.2, 0.10, 100. So what is the available moisture actually? Depth of available moisture or maximum storage capacity, that means 12.8 centimeters. So now what is the depth of irrigation? Basically irrigation water, I have put total depth. Now what is the depth of irrigation water? If you see it, out of this actually the moisture content determine the storage capacity. First thing is over. Irrigation is water is applied when moisture content falls to 14%. That is the lower level. So now you see, so depth of irrigation water that is going to be applied is equal to same formula only this time actually moisture content he told that it has fall down to this. So that I have used it and found out what is this. So now in that what he meant, because before this is what is the maximum storage capacity. For the maximum storage capacity, what is the available moisture I have found out. Now after irrigation, how much depth of water during irrigation I found out. Now field, this requirement is 75% is efficiency. So this is the thing. So both the things, storage capacity I found out, and then this also I find. Next problem. All problems are same one. The field capacity of a certain soil is 20% and its apparent specific gravity is 1.6. Apparent specific gravity means gamma D by gamma W. Before applying irrigation water, a wet soil sample was taken and its mass was found to be 150 grams. The wet soil sample. The same sample is weighted as 136 grams after oven drying. Right? Determine the depth of water that must be applied to irrigate the soil to a depth of 0.9 meters. Gamma D by gamma W, 1.6. Now the soil is actually, when it is in the wet shape, the weight is how much it is? 150 grams. Then if we put the same thing in the oven, so naturally all the moisture content is released. So its weight is 132, right? So naturally, what is the moisture content before irrigation actually? 150 minus 132 divided by 132. So 10 point. So this 10.29% of moisture is available before you apply any water to the soil. Kindly remember it. Now depth of water required to bring the moisture up to field capacity, right? So what is the depth of water? It needs to be applied. Gamma D by gamma W into D, field capacity minus moisture content before irrigation. So gamma D by gamma W is this, and what is he has given is a total must be applied to depth of 0.9, 0.2, 140. After how many days will you irrigate in order to ensure healthy growth of crops? If field capacity of soil is 35%, permanent wilting coefficient is 15%, density of soil is 1200 kg per meter cube, effective depth of root zone is 900 mm, daily consumptive use of water for the given crop is 15 mm. Take readily available moisture content as 80% of the available moisture content. So first let us start. Available moisture is equal to gamma D by gamma W into D into field capacity minus wilting coefficient. So what is available moisture? He has given what is the thing. So 1200 into 9.81. Why I have put 9.81? So 1200 kg per meter cube he has given into, I want to convert into Newton per meter cube. So I converted it. And weight of, this is a unit weight of water. So gamma D by gamma W. And what is this 90 actually, from where this 90, what is the effective depth of root zone? That is 90 mm. Then what is the thing, what he has given actually field capacity 35%. What he has given actually wilting 0.15, 15%. So use it, you got it. So now what is the available moisture? Depth of available moisture 0.216 meters. Out of this, how much is the readily available? 80%. This I calculate. So readily available moisture by consumptive use will give you irrigation interval. Irrigation interval is equal to what irrigation interval suggests after how many days again you need to supply water to the crop. So that's what it speaks. So readily available moisture divided by the consumptive use, that means what the amount of water that is being effectively used by the plants is equal to 11.52. But that means what? For every 11 days, whatever the readily available moisture is consumed because of the evaporation, transpiration, but then that is being consumed in how many days? 11.5 days. That means after 11 days, you need to again supply the water actually. Like that, for every 11 days or 12 days, you need to supply water to the crop. So 11 days is safe. This is the thing. So with that actually, we have completed the problems also in this particular topic.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.